Okay, here are our solutions on the chain rule. Starting with number 7. This is a nice little one. It's 3 in front. Exponent becomes a 2, multiplied by the derivative of what's inside, and we get a nice 12, 4x minus 1 squared. All right, next problem is 13. This guy has a radical in it, and I don't like working with the radical symbol, so I'm going to rewrite this with an exponent. And then same thing, exponent in front, subtract 1, multiply by the derivative of what's inside. I'm going to simplify this a little bit. This is going to be 4x over cube root of 6x squared plus 1, but all of that squared. Okay, next problem is 15. 15 has another radical, 4th root. I'm going to rewrite this again. So there's a 2 and then a 1/4. So the derivative, we're leaving the 2, 1/4 in front, subtract 1, multiply by the derivative of 9 minus x squared, which gives us negative 2x. We do have some cancellation here. So let's see, the 2 and the 2 with the 1/4. That's pretty nice. So we still have this negative x, and that's going to be over the 4th root of 9 minus x squared cubed. All right, 19 looks super interesting. I'm going to change the t's to an x because my t's can look like plus signs. Okay, so there are a few things that we can do. We can do quotient rule within chain rule, but I think I'm going to rewrite this. This is x minus 3 inside to the negative 1 squared, which is just x minus 3 to the negative 2. So that's easier for me to take the derivative of. The derivative of what's inside is just 1, so that's pretty lovely. So we've got negative 2 over x minus 3 cubed. All right, and if you use the quotient rule, you would have gotten an equivalent answer. Okay, 21. 21 has a radical in the denominator. I'm going to write this as 3x plus 5 to the negative 1/2. We can have 1 over 3x plus 5 to the positive 1/2 and use the quotient rule. That's up to you. We should get the same answer. All right, so negative 1/2 in front, exponent becomes negative 3/2. Then multiply by the derivative of what's inside. So we end up, this is negative 3/2 times this stuff here, and if I write it over, that's our answer. Okay, so that's 21. Next is 23. I'm not sure I've got room for that. Okay, 23. I've got x squared times x minus 2 to the 4th. Okay, this is a nice product rule problem. We could expand all that, but that sounds horrible. So first, derivative of the second. And now the derivative of what's inside is just 1 plus the second times the derivative of the first. I'm going to rewrite this a little neater because then I can see what I can factor out. It looks like both of these have a 2x, so that comes out. And they also both have an x minus 2 cubed. So what is left inside? From the 2x, or from the 4x squared, we're going to have a 2x. This guy is completely gone now. Plus, we took out the 2x, but we're going to have an x minus 2 to the first power. So within the brackets, we've got 2x plus x, which is 3x minus 2, and that is our answer for 23. Next, we've got 25. Let's see if we can fit that here. 25. So I'm going to write that radical with an exponent, and we're going to use the product rule. Whoops. So first, derivative of the second. So negative 1/2. The derivative of what's inside is negative 2x. Plus the second times the derivative of the first, which is just 1. Okay, we've got some cancellation. So the 1/2 and the 2. I'm going to rewrite this so it's not as messy. Now what I see here is that they both have a 1 minus x squared. So we're going to factor out a 1 minus x squared to the negative 1/2. What's left inside? Well, we're still going to have this negative x squared. This guy is gone. Plus, we took some of this out and we're left with 1 minus x squared to the first power. So in the brackets, we're going to have this 1, and then we've got 2 negative x squareds. So my final answer looks like this. 29 looks amazing. It seems we definitely got some quotient rule happening within a chain rule. Okay, so G prime. 2 comes in front. This is now to the first power, but now we have to multiply by the derivative of what's inside. So here's our quotient rule. So we're taking the derivative of this stuff here. So here we go. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator, 2 squared. Okay, I'm just going to rewrite these first 2 terms here. That's really sloppy. Let's fix that. Okay, x plus 5 over x squared plus 2. Okay, so what do we have in these parentheses? We've got an x squared plus 2 minus a 2x squared minus 10x. Okay, 2. All right, I'm going to say this is x plus 5 over x squared plus 2. And then we've got a negative x squared minus 10x plus 2 over this stuff. We could probably keep going, but let's stop right there. I feel like that's good enough. All right, that's 29. Now we've got 113a. 113a, we're given this radical that you know I'm going to rewrite. It's the 1/2, and they give us this 0.45, and the directions ask us to find the equation of the tangent line. Perfect. So 1/2 in front, negative 1/2, derivative of what's inside. I'm going to simplify that a little bit. So we've got 2x So that is 2x over the square root of 2x squared minus 7. Now we need the slope at 4. So we substitute 4 everywhere we see an x. So this is 8 over, what's in our radical? Let's see, we've got 16 times 2 is 32 minus 7 is 25, which is lovely. We don't always get integers. So 8 over 5. And now the slope of our tangent line would be y minus 5 is 8/5 times x minus 4. Okay, number 125, the directions change again, and we are finding, what are we finding? The second derivative. All right, so first derivative, 5 stays, 4 comes in front, third power, and we multiply by the derivative of what's inside, which is just -7. I'm going to clean this up a little bit. Let's see, 5 times -7 is -35 times 4, I think is 140. All right, we're going to do this again. For our second derivative, -140 in front. Whoops, not a 2, but a 3 from that exponent. And then we multiply that by the derivative of what's inside, which is another -7. Oh boy, okay. Let's see. So 3 times 7 is 21. And I'm going to cheat and use my calculator. So 140 times 21 is 2940, 2 minus 7x squared. Okay. All right, so that was 125, and we get to do this again with 127. I'm going to rewrite this as x minus 6 to the -1. All right, first derivative, -1 in front. We subtract 2, the derivative of what's inside is just a +1. So this is now -1, x minus 6 to the -2. All right, second derivative. We've got the -1, the -2 comes in front. X minus 6 to the -3, and the derivative of what's inside is 1 again. So this is 2, -3, which is 2 over x minus 6 cubed. All right, 163a and then b. So 163a is we are looking for h prime of 1. And they give us some graphs. All right, so h of x is f of g of x. Oh, that is not right. H of x is equal to that. That's what they tell us. So our derivative, we have to use the chain rule because this is a composite function, right? One function within another function. So the chain rule is the derivative of the outside times the derivative of our inside. And if we want this at 1, we're finding all of our values at 1. And I'm sure you hear my children in the background because they could only be quiet for so long. All right, so g of 1, I'm looking at my graph. If you need help with this, you're going to let me know. But looking at the graph, it looks like g of 1 is 4. G prime of 1 is the slope when x is equal to 1, and it looks like we've got a slope of -1/2. Okay, just looking at rise over run. F prime of 4, we're going to switch to x equals 4, and I'm looking at the graph of f when x is 4, and it looks like that segment has a negative slope of -1. So h prime of 1 is +1/2. All right, what does 163b have in store for us? Let's see, we're looking for s prime of 5. And Okay, so they're changing things up on us. So S of x is g of f of x, which means that S prime of x is g prime of x, so the derivative of the outside times the derivative of the inside. Okay, so we're doing this when x is equal to 5. F of 5, looking at the graph, when x is 5, f of x is 6, and the slope there is a negative 1. Then switching to the graph of 6, we want the slope. Oh no, there is a sharp corner there. So g prime of 6 is, doesn't exist, okay? It looks like our function is not differentiable there. So that's what I'm going to say, is that S prime of 5 is undefined.